Assalamualaikum and hello. Today I'm going to be answering two questions. For question 1, I chose the question C, and this is the question. Calculate the value of Vp second, VRMS second, and I average if V average is 110 volt with load resistance RL equal to 1.5 kilo ohm for a full wave bridge rectifier. So we're gonna do this step by step. First of all, we are going to calculate the value of Vp second. So to find out the value of Vp second, we have to find out the value of V out first. So to search for the value of V out, we can use the V average formula, which is for full wave bridge rectifier. The formula is V average is equal to 2 multiplier by V out and divided by pi. And then we can rearrange the formula until it became V out equal to V average multiplied by pi and divided by 2. And then we just have to insert the value, which is gonna be 110 multiplied by pi and divided by 2, and finally we will get the value of V out, which is 172.8 volt. Now that we have the value of V out, we can calculate the value of Vp second using the formula of V out, which is V out equal to Vp second minus 2 multiplied by diode voltage. So in this question, it is not given the value of diode voltage, so usually we can just assume that the diode voltage is 0.7 volt. So right here we have to rearrange the formula until we get Vp second equal to V out plus 2 multiplied by diode voltage, and then we just have to insert the value 172.8 plus 1.4, and finally we will get the value of Vp second, which is 174.2 volt. Now that we know the value of Vp second, we can search for the value of VRMS second. So for VRMS second, when we can use the formula, which is VRMS second equal to Vp second divided by square root of 2, and then we just insert the value of Vp second, which is 174.2 divided by square root of 2, and the final value of VRMS second is 122.2 volt. And lastly, we can search for the value of I average using the formula I average equal to V average divided by RL, and then we insert the value, which will become 110 divided by 1.5k, and finally we will get the value, which is 73.33 milliamp. For question 2, I decided to choose question A. So the question is, common emitter configuration is shown in figure 1a. If the transistor BC107 used in this circuit is silicon type and beta is equal to 200, calculate the value of IB, ICQ, VCBQ, IC saturation, and VCA cutoff. So first of all, we are going to calculate the value of IB. So to calculate the value of IB, we have to do the input analysis, which is right here. So to do the input analysis, we have to use the Kirchhoff voltage law, which is sum of EMF is equal to sum of V drop. As we see right here, the EMF is VCC and the V drops are VRB and then VBE and then VRE. After that, we have to turn the VRB and VRE into IB multiply with RB and IE multiply with RE. This is based on the Ohm's law, which is voltage equal to I multiply with R. And then we have a little problem here because we don't know the value of IE, so we have to change the formula a little bit. So we can use the formula that say IE is equal to IC plus IB and IC is equal to beta multiply with IB. And then we have to combine these two formula until it became IE equal to IB multiply with 1 plus beta. And then we just have to insert this new formula into the original formula, so it became like this. And then we have to rearrange the formula until only IB is left on the left side. So the formula will become IB equal to VCC minus VBE divided by 1 plus beta multiplied with RE plus RB. And then we just have to insert the value, which will become IB equal to 20 minus 0.7 divided by 1 plus 200 multiplied with 200 and plus 602 kilo. So 602 kilo ohm is the value of RB, which is we have to add the value of RB1 and RB2 together because it is connected in a series connection. So finally we get the value of IB, which is 30.05 microampere. Next, we want to find the value of ICQ. This is quite easy because we already know the value of IB, so we can use the formula IC is equal to beta multiplied with IB. So we just have to insert the value, which is 200 multiplied with 30.05 micro, and the value of ICQ is 6.01 milliamp. Next, we want to find out the value of VCEQ. For this, we have to do the output analysis, which is right here. Again, we have to use the Kirchhoff voltage law, which is sum of EMF equal to sum of V drops, and then it will become VCC equal to VRC right here, and then VCE, and then plus VRE. And just like the input analysis, we have to turn the VRC and VRE to IC multiplied with RC and IE multiplied with RE. And then according to the formula which say IC is equal to IE, we can rearrange the formula until it become like this. So we just have to insert the value, and finally the value of VCEQ is 6.778 volt. And lastly, we are going to search for the value of IC saturation and VCE cutoff. To find out the value of IC saturation and VCE cutoff, we can just use the formula of VCEQ that we used earlier, which is VCE equal to VCC minus IC multiplied with RC plus RE. To find the value of IC saturation, VCE is equal to 0 volt. So we can just cut the VCE right here since the value is 0, and then we rearrange the formula until it become IC equal to VCC divided by RC plus RE. Then we just insert the value 20 divided by 2K plus 200, and the value of IC saturation is 9.09 milliampere. To find the value of VCE cutoff, IC is equal to 0 ampere. Just like before, we use the formula for VCEQ. So right here we can just cut the IC since the value is 0. So finally VCE is equal to VCC, which is 20 volt.